Hi everybody, welcome to the Chapter 7 notes on mass wasting, also known as landslides in general. Let's go ahead and get started. So in 1995 and 2005, 10 years apart, there were two landslides that occurred at basically the same area. Conchita, California is, I believe, a little bit north of Los Angeles, and an enormous landslide took place in 2005, but it also occurred 10 years prior in 1995. Not many people had been killed in the prior event, but in the 2005 event, about 10 people did die and 30 homes were destroyed. So you would have thought that 1995 would have been kind of a wake-up call or a study. And they did do some studies after the 1995 event, but they realized that with the cost of stabilizing the hill over La Conchita, it would cost so much, and so they didn't do quite as much as they could have. Which is why the event occurred 10 years later and actually killed some people. Even so, people still want to live there, and it's a nice area right next to the sea, and so we have this, you're weighing risk versus desirability of a place to live, and so here's a place where that actually came back to bite residents. Right here is is two shots in 1995 and in 2005. You can see in 95 it just kind of came to the bottom of the hill and slumped at the bottom and maybe took out a house or so, but nobody was killed. In 2005, you can see it flowed much further down to the toe of the slope right there and actually wound up killing some people. So like I said before, generally speaking, this this concept is called mass wasting. That is, wasting just means moving downhill or kind of what's the word I'm looking for here? Kind of disaggregating, you know. And so you have a giant mass of stuff becoming unconsolidated and moving downhill. We call that mass wasting. It's always downslope movement, and it's always, of course, under the influence of gravity. If there was no gravity, then these things would not be moving downhill. So as a single, that's what coherent means, all together, as a single mass moving all at once downhill. We'll talk about flows, which tend to involve water. We'll talk about rock falls. That is things just kind of tumbling downhill like rocks, and also avalanches, as you probably know, snow does that. But generally speaking, we call all these, if we lump all these terms together, we call them landslides. All right, so believe it or not, any kind of slope is considered a landform because it means you got a side of a hill or something like that. But hills aren't as static and unchanging as we tend to think they are. They're constantly moving. Materials are moving downslope because of gravity. And so these slopes are constantly in a state of change. So we've got a couple different parts of slopes. We've got something that's called a high cliff or a free face, which we'll talk about a little bit later. At the bottom of the slope, oftentimes you'll find what's called a talus slope. I'll mention that a little bit later on. Convex tends to mean curving out. Straight, of course, means straight, not curving. And concave means curving inwards, and all of these we'll kind of sketch a little bit later, so you kind of understand the different parts of the slope and why things move down them. This upper picture right here is from Yosemite National Park, and I believe this big monument right here, well, it's this big chunk of rock, is called El Capitan, which is one of the very large batholiths or giant rocks that are sticking out of the ground and make Yosemite so majestic. But this is called a free face right here. It's just where stuff drops straight down and almost free falls for a long period of time before hitting the bottom. But where rocks do hit the bottom, it creates a pile of rubble called a talus slope, and that's what all this is right here. On a more gently curving slope, we've got a couple different parts of it. At the very top, right there, you might have soil and trees and all kinds of vegetation sticking up. This part right here where the slope starts to curve out, we call that a convex slope. Like I said before, curving out. This part right here in the middle, is the straight slope, where it's kind of the same slope all the way down, and then where it goes from being sloped to flattening out, we call that concave. So all these different parts of the slope result in different kinds of movement down. All right, once again, we've got this free face right here where stuff can just tumble straight down, but where it stops moving, all this material right here is called talus, or just kind of a pile of rubble at the bottom of that free face right there. All right, so when things fall, and this term, you know, obviously you know what falling means, but the term falling that we're going to use in a vocabulary sense means stuff is not moving down a slope, but it's just kind of falling almost through air. All right, like as if it were like a so here's the top of a cliff, and then you have your talus at the bottom right here. Stuff is just about free falling down. That's what we call falling. All right. Let's contrast that against sliding, and what sliding means is stuff is moving all as a single block, but it's moving down over a surface. All right, so here's the surface underneath, and we've got stuff on top of it that is moving downhill kind of all together. All right, that's what we call a slide. Anything that has flow in the name usually means that it involves water or some sort of liquid. Well, it's usually water. But it's not all together. It's kind of unconsolidated or a bunch of pieces, but they're bound together with water, either flowing very slow. We're going to talk about what's called creep, or moving very fast, like earth flows and debris flows, and we'll look at some of those a little bit later as well. In many cases, here we are. You have a little bit of both. It can be a combination of flowing and sliding, and we're going to look at a couple things that determine how things move downhill. What causes it? What's the mechanism of movement downhill? The type of material, that determines how fast and in what way it moves downhill. Water, like I mentioned before, that's a big thing, because water causes a lot of these materials to become disaggregated and move more like a fluid. And how fast does it move? You can have a lot of material moving downhill, but if it moves very slowly, it can almost happen without you even noticing. So I realize this is kind of small, but I'm going to mention a few terms to you. We've got rock falls, all right? That's things kind of like I mentioned in Yosemite National Park, where stuff is just about free falling down a slope, or maybe a pretty steep slope, and then piles it up at the bottom. Slump, we'll talk about a little bit later. That's where a very steep slope slides down and becomes less steep all at once. Soil slip and rock slide, both of these are where you have big masses moving as a coherent chunk down a slope that is solid underneath. Flows, like I mentioned before, involves almost like a fluid motion. Avalanches can many times behave like a fluid. Creep is kind of interesting. It sounds kind of weird, but it's a very, very slow movement of soil downhill because of water. Earth flow and debris flows are very similar. It's just a lot of materials, a lot of debris kind of mixed together with a good deal of water, which makes them flow downhill pretty quickly. Again, here's a rockfall, an earth flow, and a, where is the debris flow here? Well, we'll just say debris flow and earth flows go together. A rock slide is where you've got stuff moving down a more gentle slope, but it's still kind of just rocks in different pieces. This is slump right here. Now it's really hard to see, but slump is where you've got something that was previously steep, but now it's made itself less steep because it kind of slid down this curved back right here. We'll look at that a little bit later. Creep right here. This is interesting. This is where very, very slowly the upper layer of soil moves downhill and takes almost everything with it. So a lot of times you'll see trees and telephone poles and fences kind of leaning off to the side, kind of like that, because they've moved downhill from an upright angle to a sideways angle. So these are all different kinds of landslides. I always like seeing these pictures right here. See these trees right here? How they all have these kind of curved trunks. That meant that when they were further uphill, they were actually sticking straight up out of the ground. But as the hill moved down kind of over that convex, remember part of the slope is convex right here, the trees started like this, but then, I'll make that look like a tree, all right? But then as they moved downhill, they got tilted, but trees don't like being tilted, so they try to bend themselves and regrow straight. So a lot of times you'll see, I'll erase these here, you'll see all these curved trunks right here. That at the very bottom, that's a telltale sign of creep going on. Right here is a couple different kinds of flow all at once, but we do see a good amount of slump right there. A slump is where you've got a steep hill that becomes less steep because of almost like, well, think about you slumping down in your chair. You're sitting upright, and what do you do to slump? You kind of let yourself sag down and kind of get more of a shallow angle. That's what happens right there in slump. So what kind of forces move materials downslope? Well, obviously gravity. Everything has weight, and anything that has mass is pulled downhill because of gravity, and so it could be anything really. Vegetation. Actually, vegetation is kind of interesting because vegetation, you know, the roots tend to hold soil together, but vegetation also adds weight as well. So it's kind of a balancing act of does it help or does it not help. Fill material, that just means stuff like soil, stuff that could be put there naturally or by man. And buildings as well. Buildings also have weight. So what resists downslope movement? Well, we're going to look really at a couple different things, but the shear strength of the material is one thing that resists moving down. Shear is things moving in opposite directions very close to each other. All right, and if there's a lot of resistance right here of soil on the top, we'll say, to moving down over a solid slope, then the stuff won't move if there's a high shear strength. But there's a weak shear strength, then this stuff is going to move downhill, and the slope right here will stay where it is. So different kinds of materials have different resistance to shear or moving downhill. We'll also talk about the slope stability. And that is whether a slope is, let me just draw like a bunch of pile of, of rocks right here or pebbles or something like that. At some point, I can pile up pebbles where it becomes too steep. Like, look at that top pebble right there. That slope right there is too steep, and so what's probably going to happen is that pebble is going to tumble down a hill and make it a little bit less of a slope. All right, so we'll talk about slope stability as a function of a couple different factors. A couple other things, contribute to what forces determine whether material moves downhill. What's the material made of? You may see a video during this chapter where the one geologist talks about different materials and how they have different tendency to slip or not. The topography, that is the landforms. What's the angle? And it plays a big part. Climate, we'll talk about how our Pacific Northwest is very prone to these kinds of things because of its climate. I mentioned before how vegetation can help but also hurt. Water plays a big part, and also time as well. How much time does this happen in? If it happens suddenly, that could be catastrophic. If it happens over a short period of time, well, at least it may not take you by surprise. So these are all factors that determine the forces on slope. All right, so the Earth material type. What is it about it that determines whether this will slide downhill? Well, the mineral composition, the types of minerals, whether they are more slippery or more jagged and have more friction and more shear force, these determine whether it slopes or not. Cementation and consolidation. These are two big terms right here, but as you might recall, actually, no, we didn't talk about sedimentary rocks, we talked about igneous rocks, but if you have heard about how sedimentary rocks form, sedimentary rocks get cemented together because of kind of minerals growing in between these particles right here. So let's say we have a bunch of sediment that is laid down right here, okay? It looks like a bunch of loose rocks, but over time, let's see if I can change the color right here. I'll make these red. All right, over time you might get like little mineral grains that kind of grow in between them and hold them all together. That's called cementation. All right? How much is it cemented together? How much is it loose? That determines whether it will move or not. All right? Are there any areas of weakness? All right? That'll determine a slippage point right there. And like I mentioned before, water plays a big part. How easily can water move through these sediments right here? That's going to be a big part in whether it moves or not. Okay, so shale is a sedimentary rock. All right, so it's a sedimentary rock, very much like kind of what I drew up here. It's got very small particles that are all cemented. I'm sorry, together. And you do know the term pyroclastic. That means just kind of cinders and stuff that have been thrown out by a volcano. Both of these aren't very strong rocks, and so these will fail and cause downhill movement. Okay, another thing that determines whether something will move downhill is whether or not it is consolidated. Now, the word solid is in there, and that really just means how much does the stuff move together, or is it just a bunch of separate particles moving kind of all their own way? Unconsolidated materials means there is a bunch of separate things moving all in different directions. All right, so slumps, we'll talk about that a little bit later. That's things going from steep to less steep all at once. Unconsolidated. Also, if you have bedrock, which is basically solid rock underground, if you've got unconsolidated materials over that, it's kind of like a bunch of particles moving over a flat table. So we call that soil slip, and I'll show you a picture of that in a second as well. Any areas of weakness, certain like slip plains. All right, these are areas where chunks of rock and ground are likely to move past each other. These can cause stuff to move downhill. Also, like I mentioned before, the ability to transmit water, we call that permeability. Think of the ground as being kind of like, well, to different degrees, it's kind of like Swiss cheese. All right, water can move through some types of rock. It can't move through other types of rock as well. So permeability is the degree to which water can move through the ground. That determines if things can move downhill. I mentioned how you have like slip plains right here. All right, so all these plains, if they're exposed on an angle right here, you can have stuff move down pretty rapidly over them down towards the bottom. By the way, just for scale, right here are people. All right, at the bottom of this, these daylighting beds right here. It's called that because I believe it's because you have these kind of since they're at an angle, it kind of creates like a shadow in there. It's almost like it prevents daylight from coming in. But anyway, that's what those are daylighting beds. Soil slips occur, like I said before. Like here's bedrock right here, all right, solid rock, and then soil is pretty unconsolidated stuff, so it has a tendency to move downhill. And so this picture right here, this is exposed bedrock right here. You've got soil at the top, and then soil at the bottom. Right there, but wherever you've got that bedrock exposed, stuff moves down over it pretty quickly. All right, what else determines if things move downhill? The slope, of course, the incline. The steeper it is, the more likely it is to be driven downhill because of gravity. Debris flows can happen very easily on any kind of slope, really, because as long as you have water, which mixes with debris and makes mud, it's going to move down pretty much any kind of slope. So wherever you have an incline, you have a likelihood for debris flow, especially if you have a lot of water. Also, how high above land it is. All right, if you've got a steep slope and it's right above a flat area right there, and it's going to come down from some height, it has a chance to really gain speed and really create a lot of damage. Relief. Now that sounds like I'm relieved because I got good news or something like that. It doesn't mean that. It means relief refers to how high the land kind of changes in a certain area. All right, so this area right here would be high relief. Like these would be like mountaintops right here. Okay, this right here would be kind of low relief because you don't have a whole lot of changing going on in a certain area with regards to height. All right, so a soil slip. Now look at this. This is a pretty steep slope right here, and it's got a good deal of relief. I mean, in a short area, that's a big change in height from there to there right there. So this soil slip has a really good opportunity to come downhill and kill a lot of people because of that high incline right there. All right, climate also really plays a big part in mass wasting. Water infiltrating soil, all right, moving through it kind of like as if it were Swiss cheese. If you get a lot of rain, I mean, obviously, that's going to be playing a big part. Does the area have a lot of vegetation? Like I said before, this can do two things. Vegetation can hold soil together, but it can also add weight. And so vegetation can sort of be a double-edged sword with regards to that. If the area is dry, you're more likely to have rock falls and soil slips. Maybe not as much debris flows because it requires a certain amount of water. But you definitely, with humid regions, areas that get a lot of water, earth flows, landslides that have all kinds of different forces in them, and creep play a big factor as well. I'll talk a little bit later about how creep actually works. I mentioned before, vegetation kind of slows erosion because it has roots and stuff and adds strength, but also adds weight as well. So, like I said before, that's kind of a double-edged sword. All right, so here you have an arid area, and at the bottoms of these hills right here, you have kind of piles of talus that have built up, and here you have over here on the right-hand side, you've got a pretty humid region, but look, you've got a lot of relief and high steepness of slopes right here. So if these hills start to move, they're going to come down with a lot of force. We have vegetation here on slopes, all right? In this case, it looks like vegetation has added weight to pull material down slope, and so that added to the instability of it right here. Water plays a big part, all right? Almost always directly or indirectly involved. Slopes that are saturated, stuff's going to come down in like a big mass. All right. If the water kind of infiltrates down deeper, like pretty low underground, you're going to have slumps. And what a slump is I'll sketch it real quick, but we'll talk about it a little bit later. So you have a steep slope right here. Well, that's too steep for it to stay upright. So what happens is a lot of times you'll have this curved surface, and so the material will kind of, let's see if I can draw this right. It'll kind of slump downhill like that over this curved surface. So this just kind of sags down like that. But that's if you have a lot of water. Let me change to blue right here. If you have a lot of water deep underground that's causing this whole base of this hillside to fail. So water can cause liquefaction. We tend to think of that as being an earthquake-related term, but it happens in landslides as well. Or quick clay is kind of another name for that, where it saturates really kind of fine particles right here. And of course, time as well. Time plays a big part. I've mentioned that, and I've been saying that all the time, that everything plays a big part right here. But over time, the forces of gravity and all the forces of the elements are going to pull stuff downhill. And so it could be quick or it could be slow. But one of the things that does happen over time is chemical erosion as well, and that weakens rock layers so that stuff tends to move downhill. All right, the toe of a slope is what's called the base. All right, so here's a toe of a slope right here. Here's the toe of that slope. So as water erodes it, it makes the slope less stable. It might have been a more shallow slope at one time, but since this slope has been eroded away, now it's more steep and it's probably less likely to stay upright. Okay, here we have a slide where, and I realize this is kind of small, but you can sort of see right here is the edge of this cliff right here. But as the slide took place, like right in the middle, this top part kind of curved back a little bit because all this, let me change to red here, all that sagged downhill. So now we have a coastline that's been kind of redefined by this slide right here. And of course, you've heard about avalanches and how avalanches are typically related to snow and ice. I guess you could have an avalanche of rock as well, but typically it's related to snow and ice. All right. This happens all the time in the U.S. and Canada, especially up in the Rockies. And a couple different things determine whether it's going to happen. The steepness of the slope. Right, we call this the angle of repose. Now, repose means laying down, but You think of the hillside as laying down. If it's laying down too steeply, it's not going to be stable. Anything over 25 degrees is considered unstable. Anything under 25 degrees should generally stay where it is. But a couple other things affect that. Temperature, wetness, the shape of the snow grains, whether they lock together or not, it plays a part in that. Also weather as well. If you've got a big snow blizzard that comes through, those winds could unloose some of the snow that would otherwise be stable and send it downhill. All right, so we've got loose snow avalanches. All right, these are avalanches that kind of come downhill and just get wider and wider as we move down slope. But slab avalanches, well, just look at the name. It moves like a great big slab or like a big block. All right, these are more damaging because you've got all that material moving at once. Like I said, like a chunk of snow coming downhill. All right, and so if we have a slope that is overloaded, it's all going to move all at once. So one thing that we do is we try to identify areas where snow will move down, and what a snow chute is let's say we have a mountain here and a mountain right here, all right, and that's like a ridge, all right, and that's a ridge kind of right there. We can identify the fact that if snow builds up kind of in the middle right there, or anywhere honestly, that this area would be like a snow chute to move down. So staying out of those areas will minimize your likelihood of getting caught in an avalanche. And this is our last slide right here before the next section. All right, so these are snow chutes right here, kind of channels where avalanches tend to move down. Maybe adjacent to snow chutes might be higher areas, but what a snow chute would sort of be like a lower area where the snow would be likely to move down. So that's it for section 1. I'll catch you on the next section, section 2. Thanks for watching.